Hello students, here we are in second chapter, and this chapter is one of the important chapter because here we're going to discuss about software models. In first chapter we discussed one of the principle that called testing is context dependent. Context dependent in the sense we have to understand the model in which we are working, and we have to prepare ourselves according to that environment our testing design will going to work. So what kind of environment that are, to understand those stuffs, that factor of the testing, the environment, we have to go through the software model and environment. You got my point? Now let's see what are the software models are there. This is called waterfall model. Waterfall model is nobody using nowadays. It was a old model, but for basic understanding everybody reads that. You got my point. You have to know there is something called A for ant, B for ball before you making the sentence. So every time in whichever course you are learning about the models, the first model they're going to teach you about the waterfall model, even if this model became kind of obsolete and nobody using it. Why, I will tell you. Okay, in this model what happened is one step. In previous chapter we saw the software process, like planning, then design, then implementation, that the flow. In the same way, what happens is in this waterfall models, one step starts only when the previous step ends. You got my point? Got my point? Sorry. The first step ends, it triggers the next step. The second step ends, trigger the third step. It's like that. So for example, the second step in this model, the second step have to wait until the first one get completed. Now you get the point. So that's not efficient, right? So let's see what they're saying. First step, requirement specification. Requirement specification means the business analyst and everyone went and find the requirement from the client, from the users, you know until all the information gathered and verified. Until that there will be uh, nothing, no other step going to be carried out. They all will wait. After that, after the requirement specification, functional specification, then technical specification, then program specification, then coding will start. See, after four step coding will start. After coding start and ends, then testing guys will come into picture. So testing will happen after the product being ready. So if in this case, if you find a bug, you remember that cost escalation model at the beginning. In the specification step, if you find a bug, it just costs you $1. But in this model, if you find a bug, it will cost you 1 million, because already the code were written. So this model, nobody nowadays using this model. This model is obsolete now. But for basic knowledge, we have to see what are the steps. The steps are requirement specification, functional specification, technical specification, program specification, then coding. After coding, we are going to test. Okay, what is the next module? Sorry guys. Okay, these are the two different terms. I mentioned it because they always they always will try to trick you with same sounding words and asking the answer in options. So what is the difference? Difference between verification and validation. So verification checks, what verification checks is, it checks the working product meets the requirement set for out. Means verification tests whatever the requirement are covered or not in your products. Whatever they said, are you mentioned those or not? In validation, is based on what? Evaluation. Evaluation against user need. What user needs. Is it working in that way? So verification is totally about the specifications and validation is about the product. That is the main difference. You got my point? Yeah. Now let's go for V model. V model is kind of interesting. Now you see, if you take out these parts over here, you'll find a waterfall model here. But in this V model, what it's saying, the tester are going to be engaged from the first step itself. You see the middle part, acceptance test planning, system test planning, integration test planning, unit test planning. And guys, you have to remember this model, because they will ask you specific direct questions from a K1 level kind of questions. Kind of, for example, acceptance testing in acceptance test planning starts which stage kind of stuffs, and they will give you option this right, all the 4 steps that are in the right side, left side, sorry. So you have to remember to connect that at that time. So fine. So in this model, what happened, at the time the requirement specification are mentioned, the tester means you already will start the planning about the testing, acceptance testing. So in requirement specification stage, acceptance test planning will start. Okay, forget about the right side part for now. I will say them. Just remember, because these 2 steps, the left side and the middle one, are going to start simultaneously. As the functional specification gather, system test planning will be done. The same way, at the stage of technical specification, integration test planning will be starting. Program specification test, unit test planning will be starting. Then when coding starts, simultaneously the tester will work on the test plans. Those were already designed. Got my point now? So unit testing, what is unit testing? The white box testing, the component level testing. The test cases will be there already by the time tester starts his or her test. So it's something different than before. The test cases were made, plannings were made simultaneously in every stage of the software development lifecycle, and after coding, the tester will work on the test plan. But it's not so effective, but little bit effective than waterfall model. Then is there any other model? Let's see. This is called iterative model, or you can say kind of agile also, because nowadays they're working in this way. If small part of code is available, the design codes, module wise design. There is governments one website to design, they will design specific components, and they also once the component already they test it, they finalize it, then the next every time the cycle is continuing for every component. You got my point? So it's a rapid kind of design. This is for a big project. Let me give you some dumb examples. Let me you are making a website. Okay, in front page there is a sign up, then login kind of stuff. So let's divide. Okay, login is a component. As long as login started, all the login test cases will be tested simultaneously. Design as login. It's done. Okay, login done. Then let's go for sign up. For sign up, the cycle runs. It's kind of a every small components. Say one development life cycle. They will treat every component as a small development cycle. This is what you can call a rapid iteration model. Well, we almost done. Right? You now understand the three models. This is obsolete waterfall. In this model, left side waterfall, but the test cases planning will be carried simultaneously with the with every step of the sub SDLC. And after coding, the tester will start, you know, his or her test on the plan. And in this model is a rapid kind of model. Same suppose cycle will goes on for small, you know, different on modules, kind of a module based. Okay, let's go with them. This is interesting, guys. We always talk different kind of testing. This is very important and interesting also than anything else. Okay, so test levels. Test levels means if I give you a product, how you test, they will categorize it. Okay, means you have an iPhone, you'll see, okay, it's good, it's looking very good, it's very beautiful, the finishing is good. This is one kind of testing. Now, how the software working inside the iPhone, this is one kind of testing. Or how one, if after you know, mm, joining earphones, or how Bluetooth is working, that is another kind of testing. That's how they divide it. Okay, let's see. First is unit testing. Unit testing is component level testing. Component level testing means let for example, let's take one code. Okay, if x greater than 100, do something. If x less than 100, do something. Okay, they will take that code component and test it with some component and test that against the test cases. In that way, one program or one project have, you know, thousands lines of code. So they will take the functions, the you know, the functions that are the primary functions from user requirement documents or business document functions, and they tested the code segments, you know, small unit wise. This is very essential testing, and that is called unit testing. Now what is integration testing? Exactly the next step. When you tested the units, small units, now you try to integrate them. Got my point? And you will test how they behave when they integrated, and that is called integration testing. Okay, if x plus a, it should do that. If x greater than 10, it should do that. If x less than 10, it should do that. So now you test for a case for x greater than 10, and you already test that for x less than 10. Now you combine them and see what happens if a number is x greater than 10 and x less than 10. That's how you integrate the two functions and test that how it works for both the conditions. Or you integrated small component, you integrated them, and you see how they act when they integrate. Okay, we are out of time. Let's see, we'll finish the SMS. Okay, Big Bang integration means once after all the components we are combine them and test at once the final product. All the small components we integrated, not in less quantity, but you integrate them as a whole and test them. Top down integration process means, you know, the components, this is the main component you build first, then the small component you will integrate from top to bottom. This is the main component, and this is the small component you are assemble. You make the first component, the main component first, then you integrate the small components, you know, gradually in this order. The reverse is just opposite. You start from the small components to get the big component. System testing. System testing is nothing but how the system works, not as a whole, from end to end. They don't care about what's going on inside. You get my point? It's mostly non-functional testing. It does not care what the code are doing, but it will test how the, for example, like you are testing a website. So in this section, you in this system testing, we'll see how what it does. You're not going to see how it's doing the stuff. You're going to see, for example, is it slow? If 1,000 users are accessing that website, is it how it performing? Is it slow or fast? Is it if in future 1 million people going to access your website, is it going to perform or it's going to broke? That's how that test you're going to do. Means not a component level testing, not unit level testing. It's you're going to see how a system working as a whole. You got my point? That is what the system testing is. Acceptance testing, by name you already know that for whom you are creating that system, he is accepting it or not. Okay, if user getting the user friendly feeling, or what the user gets what you wanted from the system or not, that is called user acceptance testing. If not, then you have to remodel it. Okay guys, very clear. Alpha beta testing, you know where guys already, right? It's when website they launch beta versions, means it's not the finalized version. The users can test it, and alpha means the final version. Okay, test types we are done. Then in next class we're going to start the test types. Now we are cover test levels, that is unit, component level, integration, when we integrate the components. System testing is how the system performs as a whole, not in the component level but as a whole. The acceptance testing, sorry, is how the user accepting the program or not. Okay guys, thank you very much, and next class we're going to start our test types. Thank you very much.